This pH of this solution may be anything. We may take pH of this solution 1 or 4 or 7 or 9, 8, anything we can take. Or during titration, pH of the solution will go on change. Therefore, based on pH of solution, the position of this equilibrium will change. Based on the pH of this solution, position of equilibrium will be changing. Suppose we are doing titration. On doing titration, what happens in the sense? pH goes on changes, while position of this equilibrium also will go on change. Why position of equilibrium goes on changing? Because pH of aqueous solution changing means concentration of H plus changes. Concentration of H plus changes in the sense equilibrium position also will change. Okay, therefore under the given condition, okay, at the given pH of aqueous solution, at the given pH of this aqueous solution, this equilibrium how it is there means the ratio, this ratio is 10:1, like this is there. That means this ion minus 10 times present at equilibrium means HIN 1 time present at equilibrium, not initial at equilibrium. That is the mean. Okay, so when the ratio is like this, what is the percentage of ionization of indicator in the sense 91 percentage? 91 percentage of indicator is ionized. That means 91 percentage of ion minus is present. Just 9% of unionized form is present. So ionized form how much present? 91% present. HIN how much present? 9% is present. Now you say that under this condition, in the resultant solution, this unionized form is present, ionized form is present. Which is dominant? Can we say? Which is dominant? Which concentration is dominant? Shall we say? Which concentration dominant in the sense ion minus concentration is dominant. This concentration is dominant, we can say. This concentration is how much in the sense very less. This concentration is very less. Okay, in the resultant solution means how you got this resultant solution? You have added a few drops of indicator into this aqueous solution. This aqueous solution is having pH such that the ratio of this one, is 10:1. At that time, in the resultant solution, concentration of ion minus is dominant, whereas unionized form of indicator concentration is very less. Now you say this solution has got color of ion minus or has got color of HIN. What shall we say? This solution has got the color of ion minus or has got color of HIN. Which we can say? Color of ion minus only we can say. So ion minus color is what? That's what will appear in this solution. Okay, provided this solution is colorless. This solution should be colorless solution. Okay. Then this ion minus is having what color? That will exhibit in this solution. That means this solution will exhibit the color of ion minus. Okay, therefore if we want that means ion minus, this color will be dominant in the resultant solution if the ratio is 10:1. If this ratio is 10:1, we can say. Sir, now we will take this ratio. Now we are taking this ratio in what manner means ion minus by HIN. This ratio we will take greater than or equal to 10. We will take this ratio will take greater than or equal to 10. Then percentage ionization of indicator we'll see. Percentage ionization of indicator, how much we'll see. If this ratio is 10, then percentage ionization of indicator is equal to 91%, we can say. Percentage ionization of indicator is 91%, we can say. If this ratio is greater than 10, then percentage ionization of indicator is greater than 91%, we can say. So if the ratio in this resultant solution, if the ratio like this, then out of these two, ion minus concentration will be dominant. Then this resultant solution will exhibit the color of ion minus. Okay, so that if in this aqueous solution you have taken, you are adding this indicator, you are getting resultant solution. In the resultant solution, this indicator will have so and so equilibrium. In the equilibrium, you take this ion minus concentration and HIN concentration at equilibrium and substitute here, you will get ratio like this. If you get ratio like this, then we can say in the resultant solution, concentration of ion minus is dominant, whereas concentration of HIN is very less. Since concentration of ion minus is dominant, the resultant solution will have which color? In the sense, ion minus color will have. Okay, therefore we can get now under this condition, solution will exhibit the color of which one? In the sense, ion minus. Okay, now what is the pH of the solution? What is the pH of the solution? Now we will see. This resultant solution pH will be how much? That point we have to say. Now pH of the resultant solution is equal to how much? We will see. Now for that we will take indicator dissociation constant we will take, for which we have written like this. Then we can write indicator constant is equal to concentration of H plus into concentration of ion minus by concentration of HIN. Then we can write a concentration of H plus is equal to KIN indicator constant into HIN by ion minus. Then we will take pH for this. So pH is equal to what we can say means pK indicator plus log ion minus concentration by HIN concentration. Like this we can write. Okay. Now let us substitute this ratio. Okay. Now substitute this ratio. Take this ion minus by HIN. Ion minus by HIN is equal to 10 by 1. This ratio you substitute here. You substitute this ratio here. Here you substitute 10. If you substitute 10, how much you are getting? Log 10. Log 10 is how much? 1. Then pH is equal to pK indicator plus 1. Okay, sir. Now pH is equal to how much? In the sense pK indicator plus 1 we can say. pH is equal to pK indicator plus 1. Okay, so in this aqueous solution pH is how much? In the sense, this aqueous solution pH is equal to this much. Okay, if the aqueous solution, this initially taken aqueous solution is there, no, this aqueous solution pH is equal to pK indicator plus 1, while this indicator in this resultant solution will come for this equilibrium. In this equilibrium, the concentration ratio, this ratio is 10. Then percentage ionization of indicator is equal to 91%. Then in the resultant solution, concentration of ion minus is dominant. Therefore, this resultant solution will exhibit color of ion minus. This resultant solution will exhibit color of ion minus, we can say. Okay, sir. Suppose if this ratio is greater than 10, suppose 100 will take. Okay, substitute here, this ratio is 100, log 100 is equal to 2. Therefore, pH is equal to pK indicator plus 2. Okay. Now, if this ratio is greater than 10, suppose 100 means, then pH is equal to pK indicator plus 2. That means, if this ratio is greater than or equal to 10, then we can say pH is greater than or equal to pK indicator plus 1. Okay, so this aqueous solution pH is coming under this category. Okay, if this aqueous solution pH coming under this category, that is pH greater than or equal to pK indicator plus 1, then in this resultant solution, this equilibrium will be there. In this equilibrium, the concentration ratio comes under this category. Then percentage ionization of indicator comes under this category. Then in the resultant solution, ion minus concentration will be dominant, whereas unionized form concentration will be very less. Therefore, resultant solution will exhibit the color of ion minus. Okay, so suppose if you want the color of ion minus in the resultant solution, okay, wantedly we want color of ion minus in the resultant solution, then what should be the pH of this aqueous solution? This aqueous solution should have pH this. This aqueous solution pH should fall under this category. That's all. Okay. So during titration, what will happen in the sense pH will go on change. pH of this aqueous solution will go on change. When the pH of aqueous solution falls under this category, then the resultant solution will exhibit color of ion minus. Okay, this resultant solution will exhibit color of ion minus, we can say. So now we will see now we will see the resultant solution will show color of HIN. When that point we will see now. Okay, now we have seen so far that is what is the conclusion in the sense resultant solution will show the color of ion minus form if the pH of resultant solution, otherwise this aqueous solution is greater than or equal to pK indicator plus 1. It is a conclusion. Okay, so have we concluded? So what is the conclusion we got? The resultant solution will exhibit this ion minus form of color if the pH of aqueous solution is greater than or equal to pK indicator plus 1. Okay, this is the conclusion. Now we are going to next point. What is the next point means? This indicator will give this unionized form of color to the resultant solution. For that, what is the condition? That we will discuss now. Okay, so we are going for that discussion. So now we will take a aqueous solution. We are taking to this aqueous solution, we are adding HIN. In now we are getting resultant solution. In the resultant solution, this indicator will be in equilibrium. That equilibrium will be like this equilibrium will be there. That means in the resultant solution, HIN is present as well as ion minus is present. Now this should be dominant. This HIN should be dominant. We want like this. Ion minus should be very less. Now we can say this resultant solution will exhibit the color of HIN because HIN is a dominant. Like this we want. Okay, we want what in the sense we are taking the correctly particular aqueous solution we are taking. That means what pH of aqueous solution we have to take, that pH we have taken. We have added indicator. This indicator has got so equilibrium in the resultant solution. Now in the resultant solution, concentration of HIN is dominant, whereas ion minus concentration is very less. Wantedly we have taken like this. Now you say this resultant solution will have which form of color? This resultant solution will have HIN color only. No, this HIN is having what color? That only this resultant solution will exhibit because it is colorless. Okay, we are using indicator in the sense this should not be color. This should not have color. Okay, otherwise like this only we will use in the titrations. In the lab we will use like this only. We are using aqueous solutions in the sense that will not have color. Okay, so for that case you may ask a question that many salts are colored salts are there, then what will you do? Yes, of course is there, but generally acid base titration, this is we are discussing about acid base titration indicator. Acid base indicators we are using. That means acid base titration. Acid base titrations in the sense acids and bases are colorless only. You take whatever the acids you know. That means you might have seen vinegar in your home. Vinegar in the sense dilute aqueous solution of acetic acid. So that is acetic acid only, no? That acid, is it having color? You see that acid is not having color. Okay, vinegar is not having color, HCl is not having color, sulfuric acid, nitric acid, this and all is not having color, colorless only. Similarly, bases in the sense sodium hydroxide, potassium hydroxide, these bases also not having color. Ammonium hydroxide is not having color. Therefore this solution is colorless only. Okay, therefore you need not worry. Therefore this solution is colorless. Now this HIN is having color, this IN minus is having color. But you can say that if you take phenolphthalein, then phenolphthalein unionized form is colorless, no? Yes, of course it is correct. Many acid base indicators are there. Some of the acid base indicators will have color here, is not having color here. Some of the acid base indicators will have color in this form, some is not having color in this form. Some of the acid base indicators will have color in this form, some is not having color in this form. Like this is there. That depends on that nature. If you take phenolphthalein, it is not having color, it is having color. Okay, suppose if you take methyl orange. If you take methyl orange, this in acid form that will give red color, in base form that will give yellow color. Okay, suppose you are taking another indicator, methyl red, that gives a red color in acid form, yellow color in basic form. Okay, therefore this is having one color, this is having another color, like this we will think. Okay, sir. So this is dominating, means this concentration is dominating, means it is having what color, that color only will be appearing in this solution, because it is present in this solution, it is uniformly distributed in this solution. Solution means homogeneous mixture only, no? Therefore this HIN will show color here, sir. Now it should be dominant. Therefore at equilibrium, okay, in this solution, this is at equilibrium. Now what is the concentration ratio, how the concentration ratio should be there? Now we will take IN minus by HIN. Okay, now we will substitute this IN minus concentration at equilibrium here, HIN concentration at equilibrium here. Suppose this ratio is equal to 1 by 10. Okay, this ratio is equal to how much? In the sense 1 by 10 we will take. Now percentage ionization of indicator we'll see. Percentage ionization of indicator is equal to concentration of IN minus at equilibrium by concentration of IN minus at equilibrium plus concentration of HIN at equilibrium. Okay, so percentage of ionization of the indicator is equal to, this is what concentration of IN minus at equilibrium, it is at equilibrium, it is also at equilibrium. Now we will substitute. Concentration of IN minus at equilibrium is how much here? That is 1. That 1 you substitute here, 1. Concentration of HIN at equilibrium how much here? 10. That you 10 you substitute into 100. Percentage means into 100 we have to do. So we are getting how much percentage? In the sense we are getting this much percentage. Okay, so you see that percentage ionization of indicator. Indicator ionizes to how much extent? Means 9%. That means this IN minus present 9% at equilibrium, whereas undissociated HIN present nearly 90%. Okay, so under this situation, that means such a type of situation is possible if the aqueous solution will have particular pH. Okay, so based on pH of this aqueous solution only, position of equilibrium will be there. Okay, so this aqueous solution will have some pH. Under that condition, this equilibrium is having this ratio. If the ratio is this much, then this is almost how much present? Means almost 9% present at equilibrium, whereas it is present almost 91% at equilibrium. So it is present almost 91% at equilibrium. Therefore this concentration is a dominant. It is present almost 9% at equilibrium. Therefore, this concentration is very less. We can say this concentration is very less, we can say. Therefore, we can say it is dominant, means resultant solution will exhibit this color, isn't it? Okay. Suppose if this ratio is how much, in the sense, suppose less than or equal to 1 by 10. If this ratio is less than or equal to 1 by 10, then percentage ionization, how it will be there, that we will see. Okay, percentage ionization, and in what manner percentage ionization will be there, that we have to see. Less than 1 by 10 means, suppose we will take 1 by 100. If we take 1 by less, the 1 by 100 if you take, okay, that means here 1, here you are substituting 100, then percentage ionization will be less than 9%, you know. Therefore, percentage ionization will be less than or equal to 9.1%. So if this ratio is less than or equal to 1 by 10, percentage ionization is less than or equal to 9.1%, then we can say in the resultant solution, HIN concentration is highly dominant, IN minus concentration is very less. Therefore, resultant solution will exhibit the color of HIN. Like this, you can see. Now, how the pH will be there, that we will see. pH of the solution will see. Okay. Now, pH of the solution will take. Now we will take this ratio. This ratio 1 by 10 is there? No. This ratio let us substitute here. Okay. So we are substituting here 1 by 10. Here 1 by 10 we are substituting. In this ratio we are substituting 1 by 10. Then log 1 by 10 is 10 power minus 1. Then pH is equal to what we can say, means pK indicator minus 1 we can say. So if the pH of this aqueous solution, so if the pH of this aqueous solution is equal to this much, if the pH of this aqueous solution is equal to this much, then in this resultant solution, this equilibrium will have so and so ratio. So and so ratio will be there. If the ratio is this much, then concentration of HIN is dominant. Then the resultant solution will have color of this undissociated form. Okay. So now we will substitute this ratio will substitute. That means less than 1 by 10 will substitute. Less than 1 by 10 in the sense this ratio we will take it as less than 1 by 10. That means 1 by 100 we will take. That 1 by 100 you substitute here. 1 by 100 if you substitute, then log 1 by 100 is 10 power minus 2. Then pH is equal to pK indicator minus 2 we will get. Therefore, we can say now, if we substitute this ratio, if the ratio is like this, then pH is less than or equal to pK indicator minus 1, we can say. pH is less than or equal to pK indicator minus 1. Okay, now this aqueous solution, if the pH of aqueous solution falls under this category, that means pH of aqueous solution is less than or equal to pK indicator minus 1. Then in the resultant solution, this equilibrium will have concentration ratio this one, concentration ratio this one. Then percentage ionization of indicator is coming under this category. Then in the resultant solution, concentration of HIN undissociated form is highly dominant. Then the resultant solution will exhibit color of HIN. Okay, so now we have what is the conclusion now? If the pH of aqueous solution is less than or equal to pK indicator minus 1, then the resultant solution will have the color of undissociated form of indicator. Okay, so we got totally two conclusions. One conclusion is what, in the sense, if the pH of aqueous solution is greater than or equal to pK indicator plus 1, then the resultant solution will exhibit concentration of IN minus. Okay, so two conclusions. Have we got an idea? Sir, now we got two conclusions. Now we will take a pH of resultant solution is what, in the sense, pK indicator plus 1. Okay, pH of aqueous solution or pH of resultant solution is how much, in the sense, pK indicator plus 1. Now you say solution will exhibit which form color? Shall we say ion minus form color? Yes. Okay. So if the pH of aqueous solution or if the pH of resultant solution is this one, then we can say resultant solution will have color of ion minus form. Okay. Suppose pH of aqueous solution is greater than this much, then we can say the resultant solution will have the color of ion minus form. Okay. Next question. See, if the pH of aqueous solution is pK indicator minus 1, if the pH of aqueous solution is pK indicator minus 1, now the resultant solution will have color of which one? Unionized form. Okay. So if the pH of aqueous solution is pK indicator minus 1, then the resultant solution will have color of this unionized form of indicator. Okay, sir. Now we will take what is a pH means. pH of aqueous solution is less than this one. pH of aqueous solution is less than this one will take. Now the resultant solution will have color of which one? Unionized form. Okay, sir. So if pH of aqueous solution is less than or equal to this much, then resultant solution will have color of unionized form. If the pH of aqueous solution is greater than or equal to this much, then resultant solution will have color of ion minus form. It is dominant. That's all. Okay, distinguished color. If pH comes under this category, then resultant solution will have color of HIN form. That's all, unionized form. If pH of solution comes under this category, then resultant solution will exhibit exactly color of ion minus form. Distinguished color. Okay, so suppose if the pH is falls in between these two, that means pK indicator minus 1 to pK indicator plus 1, in between these two, then resultant solution will have which color? Is it having distinguished color? No. If the pH of the solution falls in this range means in between these two. If the pH of solution falls in between these two, then resultant solution color we cannot say distinguished. That means color of resultant solution is exactly unionized form. We cannot say. Can we say exactly ionized form? No. Then what? Mixed. Mixed means which one? Unionized form color, ionized form color, both are mixed. Both are mixed means if you mix two colors, that another color will appear like this. So distinguished color we cannot get. If we want to distinguished color, then if the pH is so and so, then only we will get distinguished color. Okay, so this is called what in the sense? pH range of indicator we will say. It is called the pH range of indicator. Okay, pH range of indicator we will say. Suppose this is how much in the sense? Suppose I will take 3.1. This is how much in the sense? Suppose I will take 4.4. Okay, now indicator will show so and so color here and so and so color here. I will take like this. Okay, indicator is giving like this color here, like this color here. 3.1 means falls under this category. 4.4 means falls under this category. We will take. You may ask that here this difference is 2 only, no, but do we get here 2? We are not getting. Actually, whatever the indicator you take, they will not come under correctly 2. Okay, more or less only will be there. Therefore, we will take the like that only we will take. Now we have taken aqueous solution. This aqueous solution is colorless. We will add this indicator into this. pH of this aqueous solution is how much means 2. Now you say this solution will appear which color? Red color only, no? Okay. We are doing titration. Therefore, pH of this aqueous solution changes. Suppose it has become 3. Now this solution will exhibit which color? Same red. Now the pH is becoming 1 because of titration. Now this solution will exhibit which color? Red only. Sir, now we are doing titration, therefore the pH of the solution becomes 4 now. Then becomes 4.4. Now you say this aqueous solution will have which color? Now yellow color we can say. Distinguished color we can say. Here what color we can say? Distinguished color, red color we can say. Up to this we can say red. From here onwards we can say yellow. Now due to titration pH becomes 5.5, like this it goes on. Now how the color will be there means yellow color will be persistent. Now this aqueous solution red color will be persistent up to this. Then here onwards distinguished yellow color starts. This yellow color persistent here onwards. What about in between? What about in between? In between what? In between what? Can you get a distinguished red color? Can the solution exhibit exactly red color? No. Can the solution exhibit exactly yellow color? No. Then in this one, in between these two, in between 3.1 and 4.4, solution will exhibit which color? Mixing of red and yellow. Mixing of red and yellow. Like this only will be there. Distinguished color will not be there. Therefore, the indicator will show distinguished color if the pH is less than this, otherwise greater than or equal to this. So if the pH of solution is less than or equal to this much, indicator will give distinguished color of HIN. If the pH of solution is greater than or equal to this, indicator will exhibit distinguished color of IN minus. If the pH is in between these two, that means pH range of indicator, in between these two, indicator will give mixed color. Mixed color means this color and this color will be mixed. That mixed color will appear here. Distinguished color we will not get. Okay, now this range we can call it as a pH range of indicator. Okay, sir. Now we will see different acid base indicators will take. In different acid base indicators, what is the pH range of indicator we'll see. At this place, what